For thousands of years, humanity has looked up at the stars and asked the most profound question: are we alone? We've built telescopes to peer into the farthest corners of the cosmos, listening for signals, searching for signs of intelligent life on distant planets. But what if the greatest mystery doesn't lie in the depths of space, but buried deep beneath our own feet? What if we're not alone on this planet, but merely the latest tenants? Hello, welcome to the Astronomy Library. The history of Earth is a story spanning billions of years. For almost all of that time, our world was a silent, alien place. Vast oceans teeming with life, continents shifting, mountains rising and falling. It was a world of dinosaurs, of colossal forests, of fire and ice. And then, a geological blink of an eye ago, we arrived. Our civilization, with its cities of steel and glass, its global networks, its insatiable drive for progress, is just a fleeting moment in a timeline of unimaginable scale. But what if, in that vast, silent expanse before our time, there was another civilization? What if millions of years ago, a technological society rose and fell, leaving no grand monuments, no pyramids, no cities to be found? The evidence, if it exists, would not be something we could find with a shovel. It would be a whisper in the geological record, a subtle anomaly that looks like a trick of nature, a cosmic glitch. This isn't a fantasy or a myth. It's a scientific thought experiment known as the Silurian Hypothesis. And it forces us to ask, what would a technological civilization look like after 50 million years of decay? How would we even begin to find the ghost of a civilization long gone? The answer might lie in the very fabric of our planet, in the strata of rock, in the ice of the poles, and in a truly bizarre discovery in a remote corner of Africa. A discovery so strange, it made scientists wonder if nature itself had built a nuclear power plant. Narrator. Our story begins, not in a remote dig site, but in the sterile high-tech environment of a French fuel processing plant in the early 1970s. This was the era of nuclear power's global expansion, and France was at the forefront. They were processing uranium, or imported from a mine in the African nation of Gabon, in a place called Oklo. Everything was proceeding as planned until a team of physicists noticed a disturbing discrepancy. The uranium they were processing was slightly, but consistently, depleted in the isotope uranium-235. This might sound like a minor detail, but it was anything but. U-235 is the key to nuclear fission, the very fuel that powers nuclear reactors. The uranium being processed had a concentration of U-235 that was lower than the standard, globally recognized percentage. This was a massive red flag. The only way to get uranium with a lower concentration of U-235 is if it has been used in a nuclear reactor. The implications were terrifying. Was there a secret nuclear reactor somewhere in Africa? Was this the first sign of a rogue state developing a nuclear weapon? The world was on edge, still gripped by Cold War paranoia, and this discovery was a potential powder keg. An urgent investigation was launched to find the source of the missing U-235. When scientists finally traced the ore back to its origin in the Oklo mine, what they found was far more astonishing than any secret nuclear facility. They discovered not just one, but 16 separate sites within the mine where the uranium ore had organized itself into what appeared to be naturally occurring nuclear reactors. These were not man-made. They were a product of nature's bizarre, intricate, and almost unbelievable chemistry. Let's break down the science, because what happened here is truly mind-bending. A nuclear reactor needs three things to operate: fuel, U-235, tres, a moderator to slow down neutrons so they can split other atoms, and a way to control the reaction. At the time these reactors were active, about 2 billion years ago, the percentage of U-235 in natural uranium was higher than it is today, around 3%, which is enough to sustain a reaction. The fuel was already in place. The missing pieces were the moderator and the control system, and nature, in its infinite genius, provided them both. Groundwater, seeping into the porous rock, served as the moderator. The water would slow down the neutrons, allowing them to split the U-235 atoms. This generated heat, causing the water to boil and turn to steam. The steam, no longer a moderator, would slow the reaction down to a crawl. The rock would then cool, the water would return, and the cycle would begin again. It was a perfect, self-regulating mechanism, a natural thermostat that kept the reaction running for hundreds of thousands of years. These ancient reactors generated a steady, albeit small, amount of energy, roughly 100 kilowatts of power, enough to run a few dozen light bulbs. It's a jaw-dropping testament to the strange and wonderful things that can happen on our planet without any intelligent intervention. It's an incredibly complex system that operated flawlessly for an immense period of time. But let's pause here. While science has a beautiful and elegant explanation for the oklo reactors, it doesn't entirely dismiss the wilder questions. After all, these were not just random pockets of reaction. The decay products of the fission were found in distinct, well-contained areas. The fuel and the waste were in what seemed to be their own separate geological zones, almost like a deliberately engineered containment system. Was this just a cosmic coincidence? Or did the very structure of the Earth, in a way we don't yet understand, manage to build something that perfectly mimicked a piece of advanced technology? This discovery is a powerful reminder that the line between a natural process and a technological signature can be incredibly thin, especially when you are looking across billions of years of history. And it's a perfect starting point for our investigation into the most compelling questions of all. If nature could build a reactor, could a civilization have existed and left behind similar, incredibly subtle, and equally confusing technological footprints? The discovery at Oklo forces us to think beyond what we know. It is a stunning example of how a complex, self-sustaining process can arise naturally, mimicking technology, but it also begs a more profound question. If a complex geological process can leave a signature that looks so much like technology, what kind of signature would an actual technological civilization leave behind? This is the central tenet of the Silurian Hypothesis. It's a thought experiment named after a period in the geological timescale, long before the rise of dinosaurs, where a hypothetical non-human civilization might have existed. The name itself is a playful nod to a Doctor Who episode, but the scientific questions it raises are entirely serious. When we look for ancient civilizations, we are conditioned to search for temples, cities, or even fossilized tools. We look for a human-like imprint. But what if we were looking for the wrong things, on the wrong timescale? After millions of years, the relentless forces of plate tectonics, erosion, and sedimentation would erase all but the most robust physical evidence. Our great cities of steel and concrete would be ground into dust, our plastic waste broken down and incorporated into the geological record, and our entire existence would be compressed into a single, thin layer of rock. To find a civilization from 100 million years ago, we need to think like geologists, not archaeologists. We need to look for technofossils. A technofossil is not a fossilized object, but a persistent, large-scale signature of a technological civilization left in the geological or atmospheric record. Think of it as a fingerprint of a lost species, not a bone. The key is that these fingerprints must be so large and so global in scale that they would survive the brutal forces of geological time. So, what are we looking for? One of the most promising avenues of research is the search for anomalous isotope ratios. Our current industrial age is marked by the burning of vast amounts of fossil fuels. This has released massive quantities of carbon dioxide into the atmosphere. But not just any carbon. Another potential technofossil would be the presence of exotic synthetic molecules. Our civilization has created thousands of synthetic molecules, like plastics and other polymers, that do not exist naturally. While these would largely degrade over millions of years, some of the most stable ones might survive as trace chemical residues within the rock record. Imagine a layer of rock with a sudden, unexplainable appearance of synthetic molecules, followed by their disappearance. That would be a powerful, if circumstantial, sign of a long-lost civilization. Finally, we would look for the presence of rare earth elements or heavy metals. Advanced technology relies on elements that are often rare in nature, such as platinum, neodymium, and lithium. The large-scale extraction and processing of these elements would leave a globally detectable signature. A civilization that mined on a massive scale would have distributed these elements across the globe, creating a geochemical anomaly that might be visible in ancient rock layers today. The search for technofossils is not about finding a ruined city. It's about looking for the subtle, persistent whispers of an industrial past. It's a search for a ghost in the machine of Earth's own geology.
The search for technofossils is a compelling hunt, but it's a search that answers only half of the question. If we were to find definitive, undeniable evidence of a lost industrial civilization, a new and perhaps far more chilling question would arise. Where are they now? Their very absence would mean they failed to survive, and that raises a truly profound and unsettling thought. It brings us face to face with the most sobering concept in all of astrophysics, the Great Filter. The Great Filter is a hypothetical barrier so difficult to overcome that it prevents a vast majority of civilizations from ever reaching a state of long-term existence or interstellar travel. It's a possible solution to the famous Fermi paradox, which asks, if the universe is so vast and so old, where is everybody? The Great Filter proposes that the profound silence of the cosmos is not a sign that we are alone, but a haunting warning that there is a cosmic obstacle so immense that almost no one makes it through. There are two dominant theories about the Great Filter's location. The first, and most optimistic, is that the filter is behind us. Perhaps the emergence of life itself is the most improbable event, or the jump from single-celled organisms to complex, multicellular life is the true bottleneck. If this is the case, then our mere existence is a triumph, a testament to our improbable luck, and we are one of the very few civilizations to have made it this far. However, the second and more frightening theory is that the filter lies ahead of us. If this is true, then finding evidence of a previous civilization on Earth or anywhere else would not be a cause for celebration. It would be a terrifying discovery. It would mean that intelligent life is common, that it arises frequently across the universe, but that it always hits a wall. And that wall, that great filter, is a challenge that we are likely to face ourselves. So, what could this filter be? Let's explore some of these grim possibilities through imagined stories of civilizations that did not survive. The filter of self-annihilation. The Sapiens Echo. Imagine a civilization. Let's call them the Sapiens Echo. That was a mirror image of our own. They mastered atomic energy, created powerful machines, and developed advanced weaponry. For a time, their planet flourished. Their cities stretched across continents. Their technology seemed to solve every problem, but their political systems remained fractured and prone to conflict. When a final global war erupted, it was fought not with arrows and swords, but with the terrifying power of their own creations. In a final, desperate act of mutually assured destruction, they unleashed their entire arsenal. The planet was bathed in fire and radiation, its atmosphere poisoned, its oceans boiled. For centuries, a nuclear winter shrouded the globe, wiping out nearly all complex life. When the dust finally settled, their once proud cities were nothing but irradiated glass and fused metal, leaving behind a unique geological layer of synthetic elements and altered isotopes. Perfect. Global technofossil of their final act. Their technology became their tomb, the filter of environmental catastrophe. The fate of the Now, consider another civilization, a race we'll call the Lithops, who were far more peaceful, but no less. Their society was built on a single, vital element that was incredibly efficient for their technology. For generations, they mined it relentlessly, digging deeper and deeper, until they had exhausted nearly all of the planet's supply. The unintended consequence was a catastrophic chain reaction. The planet's geological and atmospheric cycles were thrown out of balance, triggering a runaway greenhouse effect. The oceans began to boil, the polar ice caps melted, and the planet became an oven. The Lithops, trapped on their dying world, watched as their magnificent civilization collapsed, not from a single explosion, but from a slow, agonizing suffocation caused by their own unchecked consumption. Their legacy wasn't a sudden, violent event, but a gradual, global shift in the planet's chemical composition, a distinct and measurable layer of environmental ruin left in the geological record, the filter of the unavoidable cosmic event, the silence of the Silurians. Finally, let's consider a civilization that was wise and peaceful, one that had managed to overcome its internal conflicts and lived in perfect harmony with its planet. We'll call them the Silurians. They had built a beautiful, sustainable civilization. and were just beginning to reach for the stars. They knew the dangers of their own sun, but a cosmic threat was something they couldn't predict. One day, without warning, a massive stellar flare from a nearby supernova, light years away, washed over their solar system. The burst of gamma rays and high-energy particles was brief but devastating. It was not enough to destroy the planet, but it was powerful enough to wipe out all of their unprotected electronics, erase their digital archives, and deliver a fatal blow to their global infrastructure. The Silurians, with no technology to protect them and no way to communicate or coordinate, were plunged back into a pre-industrial age. Their civilization, with all its knowledge and progress, was effectively erased in a single, silent flash from the depths of space. These stories, though imaginary, serve as powerful reminders of the potential filters that could be waiting for us. They force us to ask ourselves, which of these stories resonates most strongly with the challenges we face today? The search for a lost civilization on Earth is not just a scientific curiosity. It's an existential investigation into our own future. If we find them, and their demise was caused by a filter that we are currently facing, it serves as a powerful and perhaps final warning. It tells us that we are not special, that our challenges are universal, and that we must find a way to navigate them. The silence of the cosmos may not be empty. It may be filled with the ghosts of those who came before us, and a stark reminder of the fate that may still await us.
The journey we have taken is a testament to the power of imagination, grounded in the realities of science. We began with the strange and wonderful puzzle of the oklo reactors, a place where nature itself seemed to mimic the handiwork of a technological civilization. This led us to the compelling thought experiment of the Silurian Hypothesis, urging us to broaden our search for life beyond the typical archaeological digs and into the deep geological record. We explored the concept of technofossils, the subtle, persistent fingerprints of an industrial society that might have been left in our planet's strata. And finally, we faced the grim specter of the Great Filter, a cosmic barrier that might explain the profound silence of the universe and the absence of any living predecessors on our own world. But this isn't just a tale of ancient mysteries and speculative science. It's a mirror held up to our own civilization. The search for a long-lost past is, in many ways, a profound search for our own future. As we stand at the crossroads of our technological journey, we face the very same filters we imagined for those who might have come before us. Our carbon footprint, our nuclear arsenals, our reliance on limited resources. These are not just abstract challenges. They are the potential components of our own great filter. The possibility that another civilization on Earth may have already faced and succumbed to these same pressures is not meant to be a terrifying thought, but a sobering and critical warning. The great physicist Enrico Fermi once asked, "Where is everybody?" Perhaps the true answer isn't a cosmic mystery. Perhaps the greatest secret of the universe is that civilizations are not annihilated by aliens or cataclysms, but simply by their own choices. They burn too hot, too fast, and consume their own foundation. The silence we hear in the stars, and the silence we might one day find in our own planet's history, is not the silence of nothingness. It's the echo of 1,000 possibilities that never quite made it. So, as we look to the stars, and as we dig into the ancient rocks beneath our feet, let us not just search for an answer to a scientific question. Let us search for a lesson. The greatest legacy of a lost civilization would not be a surviving artifact or a ruin, but a cautionary tale woven into the very fabric of our world. A tale that reminds us to be good custodians of this planet, to be wise stewards of our technology, and to understand that the truest measure of a civilization's success is not how far it reaches, but how long it endures. Our future, in a sense, is our last chance to prove that we can get through the filter that might have claimed them. If this deep dive into the mysteries of Earth's past has ignited your curiosity, be sure to hit that like button to let us know. What do you think about the Great Filter? Is it behind us, or are we still heading towards it? Share your thoughts in the comments below. And if you want to continue exploring the cosmos, the history of our universe, and the biggest questions in science with us, then make sure to subscribe to the Astronomical Library and click the notification bell so you never miss a video. Thank you for watching, and we'll see you in the next one.